In this video, class 11, I want to discuss a couple of numericals with you, which of course are based on addition of vectors. So let's look at the first question. Two vectors 2p and 3p are inclined at an angle theta with respect to each other. So the question talks about two vectors 2p, 3p and the angle of inclination between them being theta. Then after the question says, keeping the magnitude of the first vector fixed. Okay, so understand what each word is saying over here. Keeping the magnitude of the first vector fixed, if the magnitude of the second vector is doubled. Now look at the slide. If the magnitude of the second vector is doubled, meaning, okay, so this is the second vector, so you're increasing its magnitude to 6p. But remember, the direction of 6p and 3p is the same. Don't forget that. Okay, so magnitude of the second vector is doubled. Then what the question says is the resultant vector also gets doubled. So when the magnitude of the second vector is doubled, the resultant of these two, okay, the magnitude of the resultant of these two vectors is also doubled. Then after the question says find theta, that is the angle of inclination between these two vectors 2p and 3p. So you can draw the picture like this. This is your 2p, this is your 3p, okay, this is a 3p, and the angle between them being theta. All right, so when we are to add 2p and 3p, okay, we of course are using the parallelogram rule over here. Okay, so we complete a parallelogram, okay, by dotted lines, and this is the resultant r. This resultant r is that of vectors 2p and 3p. So this is the resultant r. Now following what the question says, we are doubling the second vector. So 3p is being doubled. Okay, so this is a 6p. As you can see, 6p and 3p, they have the same direction. Okay, so to say, the angle of inclination between 2p and 6p, it's still theta. Okay, so this is a 6p. So now the resultant of 2p and 6p is again given by this parallelogram. You complete the parallelogram and you draw this diagonal. Now according to the question, the magnitude of this diagonal, of this resultant, is twice that of this r. Okay, so this is 2r. So this is what the question says. You have to understand the question very carefully, okay, clearly, and then you have to draw the picture, remember. Okay, so then after you do that, it's not much of a big deal. Okay, then after, the magnitude of the resultant of 2p and 3p is given by, okay, so we want to find what is the magnitude of this r. It's given by modulus of r, of course, okay, square root of a squared plus b squared plus 2ab cos theta. So a is 2p, so 2p squared, 3p squared into 2 into 2p, 3p cos theta. Okay, I'm squaring both the sides. Squaring both the sides, I get r squared is 4p squared. Okay, 4p squared plus 9p squared plus 12p squared cos theta. See, this is my equation number 1. Okay, then after case 2, that is after we double 3p. So since 3p is doubled, therefore the magnitude of the resultant vector is given by, magnitude of the resultant vector is 2r. Okay, I've straight away squared this, the general equation for resultant, which is r is square root of a squared plus b squared plus 2ab cos theta. I've squared both the sides straight away like this. Okay, so now the resultant is twice r according to the question. So therefore 2r squared is 2p squared plus 6p squared. The second vector is 6p now, plus 2 into 2p into 6p cos theta. All right, I've done away with the modulus sign because without the modulus sign also I understand we are only talking about the magnitude part. So therefore from here we get 4r squared is 4p squared plus 36p squared plus 24p squared cos theta. That is my equation number 2. All right, now the question says find theta. So therefore what you will do now is, okay, after I'll only tell you what to do, you have to do it then. Okay, this is the physics part. Okay, now only thing that is left is you completing the mathematics. Okay, and the first step will be dividing equation 1 by 2. Divide equation 1 by 2. This r squared, they will divide each other, of course. Okay, you can take p squared common from both the equations, and p squared also goes. So only unknown that is left is theta, and you only deal with the numbers and see what is the angle of inclination theta. Okay, that is what you will do. Divide equation 1 by 2 and then have to proceed. Go on simplifying it. Alright, that will give you the value of the angle theta. Okay, so this is how you proceed with this problem. Now, before I start with the second problem, okay, second numerical, I want to talk about this vector, something called a negative vector. Okay, when I made the introductory video about vectors, okay, I forgot to tell you about this. So I have a vector A, alright. Now keeping the magnitude, listen to me very, very carefully. Keeping the magnitude and the direction of this vector fixed, okay, I can take this vector anywhere in space. So this would also be, so its magnitude same and direction same, so this is also vector A. So to say this is an equal vector. This vector and this equal vector, meaning this vector and this vector are one and the same. So that would be an equal vector. But what is a negative vector? You already have used this a lot of time in class 10 also, okay, when you were changing the direction of the force. So a vector equal in magnitude but opposite in direction to this vector A will be the negative vector, negative A, minus A. Okay, so a vector equal in magnitude but opposite in direction to a given vector, all right, is called the negative vector of that particular given vector. So minus A is this negative vector of vector A. All right, so negative vector means simply you keep the magnitude fixed, you only change the direction. Hope you've understood. Okay, so we proceed to the next question. If a vector A has magnitude 5 newtons, which means this is a force, okay, and magnitude of vector B or force B is 10 newtons and the angle is theta, which is 30 degrees, okay, so find A minus B. That is what the question is saying. Now find A minus B. Okay, so this is vector A of magnitude 5 newtons, okay, modulus of A is 5 newtons, okay, and this is vector B, modulus of vector B is 10 newtons, the angle of inclination between them being 30 degrees. So since the question says find A minus B, remember addition and subtraction are one and the same thing, because if it is 5 minus 3, I can rewrite this as 5 plus minus 3. Okay, so to say addition and subtraction are one and the same thing, so we are adding here. All right, so likewise, A minus B, vector A minus B can also be written as vector A plus of minus B. Okay, so to say we are finding the sum of vector A, we want to find the resultant of vector A and the negative vector of B. All right, so since this is B, so minus of B will be what? Minus of B will be a vector negative or opposite in direction but equal in magnitude to a vector B. So let us see, this is my vector minus B. All right, this is my vector minus B, remember. Okay, and what will be the magnitude of vector minus B? The magnitude of vector minus B will still be 10 Newton because the magnitude has to be the same. Only thing that is opposite is direction. All right, so understand this very clearly. So A minus B is the same as A plus of minus B. So we are finding the resultant of A and vector minus B. So resultant of vector A and this vector minus B. So we have two vectors starting from the same point. Okay, they can represent two adjacent sides of a parallelogram. So what I do next is I complete my parallelogram. You have to complete a parallelogram, don't forget that. Okay, all right, so forget about this small bit of extension, forget about that. Okay, now we already know the diagonal of the parallelogram starting from the same point gives us the resultant. So therefore this is my resultant vector. So this is my resultant vector. This R, okay, let me write over here. This R will be what? This R will be A plus of minus B. Okay, or for that matter, the magnitude of resultant R will be magnitude of vector A plus of minus B. Okay, which can also be written as A minus vector A minus vector B. Okay, now one thing you need to understand over here, what you need to understand over here is, since the angle between vector A and vector B was 30 degrees, will the angle between vector A and vector minus B be 30 degrees? Okay, the answer to which of course is no. Alright, the angle between vector A and vector minus B is, that is the value of theta in this case is, sorry, I was writing minus over here, it is 150 degrees. Theta, your theta is 150 degrees. Okay, so when you find the resultant, so when you find the magnitude of the resultant, which of course is given by a squared plus b squared, I'm neglecting the modulus sign as you can see, ab cos theta. Remember, theta is not 30 degrees. Theta is 150 degrees now. Okay, obviously you have to use a calculator. Okay, so to do that, A is 5 newtons, B is 10 newtons. Okay, so you can find the resultant, and don't forget, you have to calculate the direction also. This is about the magnitude. The direction again will be given by, say for example, this angle is phi. The angle which the resultant vector makes with our vector A is phi. Alright, so we need to calculate this phi, and in order to calculate phi, we have this equation. Tan phi is what? B sine theta divided by A plus B cos theta. Okay, B, in fact, over here is, B means vector minus B, don't forget. Alright, so to write it precisely, it should have been modulus of vector minus B plus, here also, modulus of vector A plus modulus of vector minus B cos theta. But of course, don't forget, modulus of vector B, okay, capital B over here, of course. Alright, modulus of vector B and modulus of vector minus B, it's one and the same, which is 10 newtons in this case. Okay, so I have explained you the physics part over here. Alright, so you need to calculate this, both the resultant, both the magnitude and its direction. Alright, class 11, so happy doing this numerical. Thank you.